The God particle or Higgs boson. The recently discovered Higgs boson, which helps give particles their mass, could have destroyed the cosmos shortly after it was born, causing the universe to collapse just after the Big Bang. But gravity, the force that keeps planets and stars together, might have kept this from happening, scientists say. In 2012, scientists confirmed the detection of the long-sought Higgs boson, also known by its nickname the God particle, at the Large Hadron Collider (LHC), the most powerful particle accelerator on the planet. This particle helps give mass to all elementary particles that have mass, such as electrons and protons. Elementary particles that do not have mass, such as the photons that make up light, do not get mass from the Higgs boson. The experiments that detected the Higgs boson revealed it had a mass of 125 billion electron volts, or more than 130 times the mass of the proton. However, this discovery led to a mystery. At that mass, the Higgs boson should have destroyed the universe just after the Big Bang. This is because Higgs particles attract each other at high energies. For this to happen, the energies must be extraordinarily high, at least 1 million times higher than the LHC can reach, study co-author Artu Rajanti, a theoretical physicist at Imperial College London, told Space.com. Right after the Big Bang, however, there was easily enough energy to make Higgs bosons attract each other. This could have led the early universe to contract instead of expand, snuffing it out shortly after its birth. The Standard Model of Particle Physics, which scientists use to explain elementary particles and their interactions, has so far not provided an answer to why the universe did not collapse following the Big Bang, Rajanti said in a statement. A number of scientists had suggested that new laws of physics or as yet undiscovered particles might have stabilized the universe from the peril posed by the Higgs boson. Now Rajanti and his colleagues have found that gravity could solve this mystery instead. Gravity is a consequence of masses warping the fabric of space and time. To imagine this, think of how bowling balls would deform rubber mats they sit on. The early universe was very dense because it had not had a chance to expand much yet. This meant that space-time was greatly curved back then. The researchers' calculations revealed that when space-time is greatly curved, the Higgs boson increases in mass. This would have also raised the amount of energy needed to make Higgs bosons attract each other, preventing any instability that might have collapsed the early universe. Now that Rajanti and his colleagues have revealed that the interaction between gravity and the Higgs played a major role in the early universe, they want to learn more about the strength of this interaction. This could include looking at how the early universe developed using data from current and future European Space Agency missions that aim to measure the cosmic microwave background radiation, which constitute the echoes left over from the Big Bang, Rajanti said. It could also include studying gravitational waves, which are invisible ripples in the fabric of space-time given off by accelerating masses, he said. Stephen Hawking says God particle could wipe out the universe. Stephen Hawking bet Gordon Kane $100 that physicists would not discover the Higgs boson. After losing that bet when physicists detected the particle in 2012, Hawking lamented the discovery, saying it made physics less interesting. Now, in the preface to a new collection of essays and lectures called Starmus, the famous theoretical physicist is warning that the particle could one day be responsible for the destruction of the known universe. Hawking is not the only scientist who thinks so. The theory of a Higgs boson doomsday, where a quantum fluctuation creates a vacuum bubble that expands through space and wipes out the universe, has existed for a while. However, scientists don't think it could happen anytime soon. Most likely it will take 10 to the 100 years, a 1 followed by 100 zeros, for this to happen, so probably you shouldn't sell your house and you should continue to pay your taxes, Joseph Liken, a theoretical physicist at the Fermi National Accelerator Laboratory in Batavia, Illinois, said during his lecture at the SETI Institute on September 2. On the other hand, it may already happened, and the bubble might be on its way here now. And you won't know because it's going at the speed of light, so there's not going to be any warning. Doomsday, 9 real ways Earth could end. The Higgs boson, sometimes referred to as the God particle, much to the chagrin of scientists who prefer the official name, is a tiny particle that researchers long suspected existed. Its discovery lends strong support to the Standard Model of Particle Physics, or the known rules of particle physics that scientists believe govern the basic building blocks of matter. The Higgs boson particle is so important to the Standard Model because it signals the existence of the Higgs field, an invisible energy field present throughout the universe that imbues other particles with mass. Since its discovery 2 years ago, the particle has been making waves in the physics community. Now that scientists measured the particle's mass last year, they can make many other calculations, including one that seems to spell out the end of the universe. The Higgs boson is about 126 billion electron volts, or about the 126 times the mass of a proton. This turns out to be the precise mass needed to keep the universe on the brink of instability, but physicists say the delicate state will eventually collapse and the universe will become unstable. That conclusion involves the Higgs field. The Higgs field emerged at the birth of the universe and has acted as its own source of energy since then, Liken said. Physicists believe the Higgs field may be slowly changing as it tries to find an optimal balance of field strength and energy required to maintain that strength. 5 implications of finding a Higgs boson particle. Just like matter can exist as liquid or solid, so the Higgs field, the substance that fills all space-time, could exist in 2 states. Gian Giudici, a theoretical physicist at the CERN lab, where the Higgs boson was discovered, explained during a TED Talk in October 2013. Right now the Higgs field is in a minimum potential energy state, like a valley in a field of hills and valleys. The huge amount of energy required to change into another state is like chugging up a hill. If the Higgs field makes it over that energy hill, some physicists think the destruction of the universe is waiting on the other side. But an unlucky quantum fluctuation, or a change in energy, could trigger a process called quantum tunneling. Instead of having to climb the energy hill, quantum tunneling would make it possible for the Higgs field to tunnel through the hill into the next, even lower energy valley. This quantum fluctuation will happen somewhere out in the empty vacuum of space between galaxies, and will create a bubble, Liken said. Here's how Hawking describes this Higgs doomsday scenario in the new book. The Higgs potential has the worrisome feature that it might become metastable at energies above 100 billion giga-electron volts (GeV). This could mean that the universe could undergo catastrophic vacuum decay, with a bubble of the true vacuum expanding at the speed of light. This could happen at any time and we wouldn't see it coming. 10 implications of faster than light travel. The Higgs field inside that bubble will be stronger and have a lower energy level than its surroundings. Even if the Higgs field inside the bubble were slightly stronger than it is now, it could shrink atoms, disintegrate atomic nuclei, and make it so that hydrogen would be the only element that could exist in the universe, Giudice explained in his TED Talk. But using a calculation that involves the currently known mass of the Higgs boson, researchers predict this bubble would contain an ultra-strong Higgs field that would expand at the speed of light through space-time. The expansion would be unstoppable and would wipe out everything in the existing universe, Lycan said. More interesting to us as physicists is when you do this calculation using the standard physics we know about, it turns out we're right on the edge between a stable universe and an unstable universe, Lycan said. We're sort of right on the edge where the universe can last for a long time, but eventually it should go boom. There's no principle that we know of that would put us right on the edge. Either all of space-time exists on this razor's edge between a stable and unstable universe, or the calculation is wrong, Lycan said. If the calculation is wrong, it must come from a fundamental part of physics that scientists have not discovered yet. Lycan said one possibility is the existence of invisible dark matter that physicists believe makes up about 27% of the universe. Discovering how dark matter interacts with the rest of the universe could reveal properties and rules physicists don't know about yet. The other is the idea of supersymmetry. In the Standard Model, every particle has a partner, or its own antiparticle. But supersymmetry is a theory that suggests every particle also has a supersymmetric partner particle. The existence of these other particles would help stabilize the universe, Lycan said. We found the Higgs boson, which was a big deal, but we're still trying to understand what it means, and we're also trying to understand all the other things that go along with it. This is very much the beginning of the story, and I've shown you some directions that story could go in, but I think there could be surprises that no one has even thought of, Lycan concludes in his lecture.